Factor each of the following. When factoring any polynomial, always first factor out any GCF, the greatest common factor. In order to factor a trinomial of the form x squared plus bx plus c, note here the coefficient beside the x squared is 1. We're looking for two numbers. I'll call them p and q, such that p plus q equals b. This is the coefficient beside the x. And p times q equals c. This is the constant. If those numbers exist, then the factors are simply x plus p and x plus q. If those numbers do not exist, then the trinomial cannot be factored. Often, the x will be replaced with a different expression. The factoring process is the same. It is often helpful, though, to replace the expression with a single variable, such as u. Complete the factoring using u, and then substitute back the expression for u in terms of x. For the first trinomial, note here that there is a greatest common factor of 2. We then have inside the brackets x to the 4 plus 7x squared minus 18. Note here we do not have something of the form x squared plus bx plus c because the x has been replaced with x squared. When we're doing the factoring, we still look for numbers that multiply to give negative 18 and add to give 7. These numbers are 9 and negative 2. We then have the factors x squared plus 9 and x squared minus 2. Again, note here the x is being replaced with x squared. Note also we still need the greatest common factor of 2 included with the solution. For the second question, here we have a common factor of negative 3. Note also here that the x is being replaced with x plus 7. Here I'll use a u substitution. U equals x plus 7. I can then rewrite my trinomial as u squared plus 6u plus 8. I am then looking for two numbers that multiply to give 8 and add to give 6. These numbers are 4 and 2. I can then write the factors as negative 3. I still need that greatest common factor. And then u plus 4 times u plus 2. I can then substitute x plus 7 back in place of u. I then have the negative 3, and then x plus 7 plus 4 times x plus 7 plus 2. Inside each of those factors, I can then combine the constant terms. In the first one, 7 plus 4 gives 11, and in the second one, the 7 plus 2 gives 9. I then have my final factored form, negative 3 times x plus 11 times x plus 9.